All right, guys, so this is going to be my video trying to kind of make up for those of you who weren't quite understanding the content yesterday. So I'm going to go back over briefly about line segments and especially solving those problems using the segment addition postulate. Now, I'm not expecting you to put this in your notebook or anything like that. This is just to kind of help and illustrate some things. So you can write along with me if it helps you, but you don't have to. So I started off yesterday by talking about a number line. I'll just take a moment to construct one. Okay, I didn't do a super great job on that side. That's okay. So let's imagine this number line that goes from -5 to +5. And if we were to drop points on this line, they could be representing line segments in a way. So let's say I drop A at 0. I drop B at 2. And I drop C at 5. This could be a way of representing two different line segments and their lengths. So we can imagine these two line segments that I'm talking about with A B and C. Except one has visual things that we can use to count the length. And the way that we can count our length is, very physically. We can take our pencil and count, okay, to get from A to B, I have to go 1, 2 spaces, making the length of line segment AB 2. And then to count from B to C, I have to go 1, 2, 3 spaces, making the line segment BC 3 units long. And imagine that you're building something and you take, maybe a popsicle stick that's 2 inches long and a popsicle stick that's 3 inches long, and you glue them together at each end. And then you needed to know, well, how long have I made this stick now? Will it fit where I need it to now that I've made it longer? And you can do that by adding up the two pieces. So if this one's 2 and this one's 3 more, then the entire piece should be 5. And we can confirm that with our number line by counting from A to C is 1, 2, 3, 4, 5 spaces. That's the basic idea of the segment addition postulate. If you take two smaller pieces and stick them together, you get a larger and longer piece. And this can be applied to anything physical with length. If I take two pieces of string and lay them next to each other and measure from one end to the other, it's going to be the sum of the length of the two pieces themselves. You can do it with, like I said, popsicle sticks. You can do it with PVC pipe. You could do it with literally anything that you can measure the length of. If you put two of them next to each other, then to get from one end of the first one to the other end of the second one, you would have to count the length of the two. Or not necessarily, you could just measure it from one end to the other, but it would be the combined lengths of like the red and the black pen. So we use that to solve problems in math, because there are times that we're having to figure things and we don't quite know what the dimensions are going to be or need to be. And so we can do some math to help figure that out. So if I give you a problem where there's P Q and R are collinear, and Q is between P and R. Find the length of PR if, sorry, I didn't write that very well. Find the length of PR if from P to Q is 7 units and Q to R is 5 units. Now these don't have any pictures to them because I want us to be able to represent these with pictures of our own. So you can start off with just any line, and then I know that P, Q, and R are on this line, so I'm gonna have 3 points. And it doesn't really matter where I put them. I usually just kind of space them equally, but you don't have to. And it says Q is between P and R. That means that Q is going in the middle, and then P and R are on the other side. Now I'm going to take that other information they gave us and fill that in. So it says PQ is equal to 7. So from P to Q is 7. And from Q to R is 5. So I may not be able to measure from P to R, but if I know from P to Q and I know from Q to R, I can add those two pieces together, say, oh, well, 7 plus 5 equals 12, and that'll be my total length. So that's all you have to do for problems like this. If they give you a number for piece 1, a number for piece 2, just add them together and you'll have your total and you're done. But what if they start giving you variables? So maybe let's have a similar problem where A, B, and C are collinear. And B is between A and C. Find X if from A to B is X units long, B to C is X minus 4 units long, and from A to C is 12 units long. So again, I didn't draw a picture here for you, so I'm going to talk you through how we create that picture. So again, we're dealing with a line, 3 points on a line. So 1, 2, 3. B is between A and C, so B goes in the middle, and A and C on either side. And then I'm going to go in and I'm going to label. All right, so they told me that from A to B is X units long. From B to C is X minus 4 units long. And then the whole thing is 12 units long. And now I can set up my equation where part plus part, and you can call it part 1 and part 2, equals the total. And just fill in with your parts. So part 1, we have X. Part 2, X minus 4. And our total is 12. I'm going to go ahead and rewrite that for us so we can see it a little bit better and solve it a little bit easier. So X plus X minus 4 equals 12. Now I see that I have 2 x's on this side, so I'm going to combine those because those are like terms. So 1x plus 1 more x makes 2x, and everything else carries down. Then from there, I have a 2-step equation. So first I'm going to undo my addition subtraction. So I'm going to add 4 to both sides. And that'll leave me with 2x equals 16. Then from there, how are you doing? Sorry about that, had a brief interruption. I'll continue on. So now that we're here with 2x equals 16, we have to undo the multiplication by dividing and getting x equals 8. So now that I know what x is, I've technically solved the problem, but I'm always going to show you guys the next step after in case it ever comes up in a question, because I often do ask for you guys to use x. So that means we want to know our unknown lengths. So we didn't know what AB and BC were. They're x and x minus 4, but I don't know what those numbers are. But I can use x to find out. So for the first one, AB is equal to x. Well, x equals 8. So that would be AB. For BC, it's x minus 4. So that would be 8 minus 4, which is 4. So now I'm able to know exactly, okay, AB is 8 units long and BC is 4 units long. Instead of having to just guess what they are, I was able to use their relationship to solve for that. All right, now let's do one example that's more like the difficult problem on the homework that I think was getting a lot of people. Because I'm going to be honest, I didn't even quite register that I had made all 3 of those expressions. I really didn't, which surprised me this morning when I looked at it and I was like, man, I really assigned them that, huh? Anyway, it's not as if it's something that you couldn't handle. With the right tools, all of those problems are completely doable, but it's okay to struggle and it's okay to need to go a little bit slower and take things in a little slower. So there's no shame there. I just want to make that clear that I'm not saying like, oh, you should have gotten it right. I understand, everybody takes things at a different pace and I did go pretty fast. All right, so the problem was similar to find x if y is between x and z and the length of xy is 2x minus 6. The length of yz is x plus 7. And the length of xz is 2x plus 9. That seems like a lot of expressions that they're throwing at us. Now, always start off with drawing a picture. That's going to be your best friend in geometry. So, okay, I'm talking about a line. And on this line, y is in the middle of x and z. They're not quite in the middle, but between. From x to y is 2x minus 6. From y to z, I have x plus 7. And from x to z, 2x plus 9. So now I'm able to very clearly see my parts and my whole. So I know how to set up the equation. I really would advise you guys not to guess by looking at the problem where your parts and your whole are, because they could always trip you up. It's not always going to be part, whole. Maybe a test question is trying to trick you and puts the whole first. You want to make sure you're actually really thinking about each piece. All right, so again, we're going to be using part plus part equals whole. And we're going to put each of our parts in. So 2x minus 6, x plus 7, and 2x plus 9. And then from here, we can solve our equation. So again, I'm going to rewrite it so we can see it a little bit easier all in one line. 2x minus 6 plus x plus 7 equals 2x plus 9. That's a lot going on. It might seem a little bit overwhelming. I mean, we have a bunch of different terms going on here. But using this basic rules we went over with solving multi-step equations, you absolutely can tackle this problem. So first, let's think about our like terms. So I've got some x's in here. And I've got some constants. So I'm going to want to combine those. So 2x plus 1 more x makes 3x. And negative 6 plus 7 more would be the same as 7 minus 6, which is positive 1. And that's equal to 2x plus 9. I didn't change the other side of the equation, so I just drop it down. Now we're dealing with one that's like a variable on both sides of the equation, and your multi-step equation notes will have an example just like this. From there, I want to get all of my x's on one side, so I'm going to move my smaller x value. That makes my work a little bit easier by keeping things positive. So 3x minus 2x is 1x. And then we're left with x plus 1 equals positive 9. And now I have one step left. Subtract 1. 9 minus 1 is 8. And I now have my value for x. So again, even though that problem seemed a little bit overwhelming, we did addition, we did subtraction, we did subtraction. And that's what the problem boiled down to. Those are all things that you absolutely can tackle. You just have to make sure you keep your work organized and use your algebra notes that we took as a reference. Now, the problem like this didn't stop there. It also wanted to know, well, what's xy, what's yz, and what is xz? So we actually had to go in and plug in our variable. So in each of the equations up here, I'm plugging in 8. So 2x minus 6 for xy, x plus 7 for yz, and 2x plus 9. So starting from the top, 2 times 8 is 16. And then we have minus 6 makes 10. YZ is 8 plus 7, which makes 15. And 2 times 8 is again 16 plus 9 makes 25. Oops, sorry. And I like to do this step especially to check my work. Do the two parts actually add up to make the whole? 10 plus 15 does indeed make 25. So that helps me know that I did the problem right. So I hope that by giving you an example that very closely models the assignment, that you guys are able to recreate the steps I took for the assignment. I also hope that this video helped you to better understand the processes that were taken. But again, if this still wasn't enough, just reach out to me on Schoology. I'm going to be putting out some more resources about this because I know sometimes the way one person explains it just won't click in the long run. So I'm going to find some other people explaining it, maybe some other types of notes, and see if those can help you out as well. All right, I'll catch you in the next video.